So here we have a question paper done last year, diploma in land surveying, November series 2022. So that was done last year. Here we have a question I want us to tackle in curves, which will help us more. So the question goes by, so the figure 2 shows a proposed circular curve in which the intersection point I of straights PI and QI are not accessible. Measurements were carried out in the field as follows. So distance BD is equals to 1000. Then we have here, so this was supposed to be a point of correction there. So this was supposed to be PB. So PB is equals to QD. So as you can look in the diagram here, so PB, so this distance is the same as this distance, so we cannot have PQ. So this information, yeah, so PB is equals to is the same as the Q. Then we are given the angles PBD, so those are the the external angles here. So PBD is that angle, and angle Q, angle QBD, it's given here. If the radius of the curve is 1600 meters, use the information given above to compute the distance of P to T1, so P to T1 and Q to T2 respectively. So a total of 13 marks. So here the question, I've already done that. So in order for us to find the internal angles here, you subtract 180 because the lines on a straight line add up to 180 degrees. So having subtracted 180, you get the angles, the internal angles of the triangle here B and the angle of D. So that will be the two. Having done that, in order for us to find the angle of intersection here, we'll have to minus the total summation of those two angles minus so the addition of those two angles, 180 will be subtracted from that, and our intersection angles become 70 degrees. We use the simple concept of comparing the angles to lines. So this is found in triangulation, mathematical, so enlargement somewhere there. So the distance ID over sine 50, the opposite angle over sine 5612 is the same as the distance I to B over the opposite of sine of that angle is equals to the distance which we have already been given in the question. So the distance is there over sine angle of intersection. So by comparing all those, you'll have found the two distances. So ID will be 1313, and then the second distance for I, so ID will be that, and then IB will be here, will be the same as that. So after calculating that, we go ahead, we find the tangent length, so the tangent points. So the question, in the question we were needed to calculate the, so let's go back. So they need us to compute the distance P to T1 and Q to T2. So we go ahead and we calculate the tangent length. From the tangent length, we subtract the distance that we have there, having So that is the tangent length. After having the tangent length, we subtract that distance, the distance that we had earlier. After subtracting it, we find our value for so that will be the distance of P to T1. Then we do the same. So the tangent length, the second tangent length, will subtract it. So we'll have to find the, so that is the tangent length minus the second distance that we had calculated there. So when you go back here, so our tangent length, it's a little bit higher, but that is our tangent length. So those will be, so the radius was a little bit bigger, yeah, that's why our tangent length are bigger. So we do the same for Q to T2. We subtract and we find our answer. So the distance we had already calculated there. So in order for us to, so the tangent length we already calculated it there. So we subtract it in order for us to find the distance given there. So in this question, so we have already calculated those two, so I don't think we don't even need to find any other. So this is the distance, so the distance of so our distance will be, so that will be PB. Here PB will have already calculated that distance, and that distance is what will subtract. So 1200 minus the answer that we have there, and we repeat it to the next point and finish the values. So that will be